Find the Taylor series for fx equals 5 over x, center at a equals -2. Okay, so we want to express 5 over x in terms of a Taylor series. We know that for the function f, the Taylor series is given by this formula, Cn x minus a raised to n, where n runs from 0 through infinity. A is the center, and these constants Cn's are found by this formula. So f parenthesis n means nth derivative of the function evaluated at center A divided by n factorial. Okay, so for this function 5 over x, the center A is -2, so x minus -2 means x plus 2. So we need to determine Cn's, and Cn's are given by this formula. So we want to find a couple of like C naught. C naught would be 0th derivative, means the function itself evaluated A divided by 0 factorial, nothing. 0 factorial is 1. So we'll find this one, we'll find C1. 1 means first derivative of the function evaluated A divided by 1 factorial. So after finding a couple of C values, hopefully we'll have a general form for Cn. And as soon as we have that Cn, after we figure out the pattern, then we plug Cn back here and we get the final answer. Okay, so let's make a table and let's figure out a couple of Cn's. So n0, 0th derivative of the function means the function itself, and we can write 5 over x as follows. 5 over x is just 5 times x raised to -1, so that it becomes easier to find the derivative. So this is 5 over x, or 5x to the -1. We need to evaluate it too, but when we evaluate, it's better to plug in here 5 over -2. So this will be 5 over -2, and this is C0 because n equals 0. So we divide this by 0 factorial, means 1, divided by 1 means nothing. So 5 over -2. So I want to write in this way, -5 times 1 over 2. In fact, in this function, this 5, we could have just dropped 5 and found the Taylor series for 1 over x and eventually multiply by 5. That would be fine. Okay, that would work as well. So that's why I want to separate this 5. That is for n equals 0. Let's look at n equals 1. F1 means find its derivative. So from the power rule, -1 times 5 is -5x n minus 1. -1 minus 1 means -2. Evaluate this at -2. So this is in fact -5 over x squared. -2 squared would be +4. So -5 over 4. So I'm going to write 5 over -5 over 4. And 1 means divide by 1 factorial. So itself. So I'm going to write in this way, -5 times 1 over 4. Okay. Let's do for 2. So after we find a couple, maybe 4, we might be able to see the pattern. Okay. Now let's find the derivative here. So -2 times -5 is +10 x n minus 1, -3. Now we evaluate at -2. So that's the 10 over x cubed. 10 over -2 cubed. That's the 10 over -8. So this will be -10 over 8. Let me write. Now we need to divide by 2 factorial. Look at the formula here. Divide by 2 factorial. So 10 over -8, divide means put on the bottom, 2 factorial means 2, and 2 goes this 5 times. So -5 over 8. So negative 5 1 over 8, right? Negative 5 over 8 is this one. Now we kind of have the pattern 1 over 2, 1 over 4th, 1 over 8th. If we try the third one, it would be negative 5 1 over 16. Let's see. I mean, that's kind of not needed because we already saw, but let's be certain 200%. Find the derivative. So negative 3 times 10 is negative 30 x negative 4. That is negative 30 over x4. X is negative 2 to the 4th. So negative 30 over 16. Now divide by 3 factorial. Okay, using this rule. So we got divide means on the bottom. 3 factorial. 3 times 2 times 1. That's a 6. And 6 goes how many times? 5 times. So negative 5 over 16. So negative 5 over 16 I can write in this way. Yeah, exactly like what we have said earlier. So now we have the pattern. We know how to write down Cn for all n's. I mean, we tried for 4 of them. So from this pattern, we can see that Cn will be negative 5, negative 5, negative 5 for all of them. 1 over 2, 1 over 4, 1 over 8. So 2 is squared, 2 cubed, 2 raised to 4. So 1 over 2 raised to n power. When n equals 0, we have to get 2. 2 raised to 0 is 1, but this is 2. When n equals 1, we have to get 4. So 2 raised to 1 is 2. So we are missing. So this will be 2 raised to n plus 1. Because n starts from 0. So 2 raised to 0 plus 1 is just 1. 2 raised to 1 is 2. When n is 3, 3 plus 1, 4. And 1 over 2 raised to 4 means 16. So we have that. So this is true for all n. So we simply go back and plug in here. Thus, the Taylor series for this function centered at this one is, or we can write this function 5 over x equals sum n from 0 to infinity of negative 5 times 1 over 2n plus 1. We can write negative 5 on the top. X minus a is negative 2. So x minus negative means plus 2 raised to n. Okay, so this function is represented by this power series. Final.